Okay, what we'll look at here, since some of y'all hadn't had intro to robotics, this will be a review for some of y'all. There's going to be some material in here. And then, of course, if you hadn't had intro to robotics, you need to pay pretty good attention here. So we're going to look at basic robotics, and key terms we'll talk about is end-of-arm tooling. We'll talk about grippers, T-spins, controllers, about the different types of memory in the computer, about the speed, maximum speeds of the robot, and then something called memory capacity. And then, of course, additional terms will be introduced during the presentation. What is an industrial robot? We're not talking about a robot in general. Unfortunately, we use the term robot for a lot of different things. But we have we have the International Standard Organization, which is ISO, which sets international standards. And then we got RIA, which is the Robot Industry Association, which was predominantly originally established in the United States. Both these guys have set up what they determined to be what an industrial robot is. So this is a robot that's used in industrial application. So that's going to eliminate a lot of the robots that you see. So, you know, if you watch Robot Wars on TV, which is pretty neat, ISO would not consider that to even be a robot. Robot Industries Association, IRA, would consider it to be what they call a Class A robot. So IRA is a lot more lenient in what they define as a robot. What they did is they set up five categories of robots. So what is a robot? Oh, so it's yeah, but we have a lot of programmable machines that would not be considered to be robots. So this right here, this computer I'm setting in front of me is a programmable machine. PLC is a programmable machine, right? The ATM that you put your checks in is a programmable machine. So we have a lot of programmable machines, and none of those would be considered to be a robot. Number one, it's got to manipulate something. So an industrial robot moves something around, right? You understand that? So it's got to manipulate something. So in the ISO, it's an automatically controlled, reprogrammable, multi-purpose manipulator programmable in 3 or more axes. So our Robot Industries Association, IRA, is a lot more lenient in their robot. ISO actually comes up and says you got to have 3 axes before we consider you to even be an industrial robot. And what is an axis? Well, what is an axis? So we can't say the Earth rotates around an axis. So we can't say the Earth is a robot, even though we have a lot of people and stuff that acts like that. But so what is an axis? Yeah, what is an axis? This says axes because it's more than 3, so it's plural for axis. So but we're looking for an axis with an I instead of an E. An axis is a point about which something moves. So the Earth rotates around an axis. So we have a point, or they actually put a line through it. You ever seen it? So we actually rotate at a tilt. So the Earth rotates at a tilt, which if it rotates at a tilt and it moves around the sun at a tilt, then what that does, that's what gives us our seasons, right? You understand? Which is pretty nice. So we rotate around an axis. We have 2 categories of axis. What are the 2 categories? Anybody know? One of them is, of course, rotational, which means they move in circles or arcs. The other one would be what we call a linear axis, which means it moves in a straight line. Everybody okay? This is IRA. IRA says an industrial robot is a reprogrammable manipulator. Multifunction. Of course, what does multifunction mean? Yeah, we can make it do more than one thing. Of course, usually we have to change the tool out. But so I can see an ABB robot, that robot right there. You can look up that robot, and on YouTube, and you would see it doing a lot of different things. The same robot doing a lot of different things. Right? A manipulator, which means it's got to move something around, right? You understand? Designed to move material, parts, tools, or specialized devices through a variable programmable motion. Variable, when we use the term variable, what is variable? So in math, we use variables. We have constants and we have variables. What's the difference between a constant and a variable? Variables can be easily changed, right? Constants are always going to be the same. So pi, what would pi be considered? Not the eating pie. That is a constant. I mean, pi never changes, right? You understand? Pi is a constant. So we'll be dealing with variables in this class, and we'll be dealing with constants. We need to understand the difference. In programming, a variable is something that can change without changing the program. A constant means you literally have to change the program to change what it does. That makes sense? So the speed of the robot, we can change the speed of the robot without changing the program. But if I wanted to change the way I wanted the robot to move, let's say a joint move over to the linear move, we would have to change the program. Programmable, variable programmable. So that means we can change the program motion for performing a variety of tasks. So RIA does not specify the number of axes the robot has. Reprogrammable, of course, is a device whose activities are controlled by a stored program that can be what? Changed. Multifunctional means it's capable of performing more than one function or task. The field of robotics, which some of y'all are trying to get into, and of course this is the study and design and the use of robot systems for manufacturing. And this came from the world famous site Wikipedia. When Wikipedia first came out, you took everything that was on there in a grain of salt, but they would let anybody, any place update. That was really, really good. They have people that go back and review. You have to have it reviewed by so many people before they'll actually post it. So most of the information up there is really, really good. The definition of a manufacturing system: production, hardware, program, and personal organization into an interactive group for the purpose of converting raw material parts and information into products and services in the world market. So basically, to be a manufacturer, you have to take raw material. U.S. Steel would be considered to be a manufacturer, or used to. Well, they'll even if they put the, yeah, I guess they would still be, because they still take raw, even though, so the metal would be your raw material, and then they form it into, they literally change its shape and form it, so it's still a manufacturer. Mercedes would be more considered to be an assembly plant than a manufacturer, because everybody else takes the raw products and makes it for them, and basically what they do there is just do what? Yeah, put it together. What can an industrial robot do? So I got my little drawing pen out. We'll try to make a list. What do y'all think? What can it do? What can we get these things to do for us? Yeah, we can weld. They can paint. What's that? Yeah, we call it pick and place. That's just moving stuff. We have a lot of robots. That's what they do. They just pick and place. So when we look at our manufacturing line, the Festo has 2 robots. That's all they do. They just transfer information around. Machine tending, which would be another pick and place, where they just basically just load and unload machines for us. Anything else? Yeah, transport to move stuff around. Yeah. They had some robots up at the Bridgestone plant when I went to the level 1 Siemens training. They called them minions because they were yellow, portable robots. And what they did is they transferred the tire around to different places while it was being assembled. It would sit on top of that thing, and those things just run around. And, so it was pretty neat. And they were all over the place, and they have a little bit of tire on top of them. They'd be rolling around. They'd move to different places that they do. It was really, really neat. So that's all their purpose in life was machine tending. All they did was move things from machine to machine. But the machines were so far apart, they didn't do it with like a transfer line where they go, where the machines are side by side. You know, so they go to one machine and they'd set that tire on top of it, and it'd start ripping around inside these things. And they were really neat. If they ran into something, they would try to figure out how to get around them. So we were looking at the control panel. So one guy sits there and runs all of them. I don't know how many they had. They was all over the place. And they had 3 big monitors up there so they could tell what they was doing and all this kind of stuff all the time. And the little place they came and parked was right beside this thing. And I couldn't walk, of course, so we rode us around in a golf cart. And when we parked behind the control for all the minions, they couldn't figure out how to get around the golf cart, and they was behind us. We had about 8 of them behind us, and they was all running around. You know, it was so funny. Finally, comes and said, "Hey guys, y'all gotta move." So yeah, they was trying to go this way because I guess it was wider than a person, and which was pretty neat. But yeah, we transport stuff around. What else can we do?
Our front line, we had robot panic applied seat.
Yeah, so we can have an applied. So that would be paint apply. So adhesives. We have if you went to Mercedes, they got some plants down there that just puts adhesives around the doors and everything, so they can put all those panels and everything up there. I don't know what I'd say. Apply. Anything else? We can have them assembled. So the little Mitsubishi robot on the Festo line is an assembly robot. That's all it does, is puts it together. The robot on the Amatro line is a machine tending robot. What it does is the line puts it together, and what the robot does is just move the part between the different parts that puts the parts together. So that would be a pick and place, or we call it machine tending, which we should put that. I accidentally hit the key. Let's see if I lost it. So machine tending. So we lost some of them. I'm not going to put them back up here. So that's what they do. They just unload. If we went down to, I think it's gas pump. They do press down there, and they have robots they're between the big old presses, and they'll go in and pick it up and then move it over to another press, which is pretty neat. And that would be machine tending. We have videos where the robot is running programmable lathes, and then the robot just goes in and loads the part into the lathe, and then when it's through, it unloads it instead of having a person sitting there that does it for you. Anything else? So let's see if we got the list up here. So material handling, machine tending, they can weld, they can paint, they can assemble, they can pick and place, they can pack stuff, they can palletize stuff, they can clean, they can glue, they can mill, they can drill, they can test, they can cut, they can grind, and the list could keep going on and on. These guys are programmable manipulators. And that would be saying, where can I go in my car? That's basically the same, right? Because you determine, you get in that sucker and you drive it, right? And you can go a different place all the time. So it's anything that you can do with your human hand, anything you can grab, anything you can grip, so we can do it with a robot. And then, of course, now we got mobile robots, that can do a lot of things. Thank God, when the Event Horizon went down, that thing was down how many miles? It was way down there. Way down there. And there's no human that could have went down there, but the robots did, right? You understand? We have drones flying all over the Middle East over there that are robots. So there's not somebody sitting there flying those things all the time. They program them suckers where they want to go, and they just go out and go, right? You understand? So that we have mobile robots, we have aerial robots, we have, underwater robots, that does things that people, not only can we do them faster and more accurately, what we can also do is do things that humans can't do, or humans don't want to do. So they don't mind dirt, they don't mind grease, they don't mind toxic gases. When 3 Mile Island had their big problem, that's what they sent down inside that. Those robots are still down there. The mobile robots are still down there because they couldn't bring them out because it was so contaminated. But we couldn't go into that type of environment, right? I don't know what they did over in Japan. I think they sent them in Japan too when they got that big Yuko plant. The next robot can do is program tasks with a high endurance, repeatability. What is the repeatability? This is what humans have problems doing, being repeatable. So we could sit down here and I could have you write a report, right? You understand? And then have you write that same thing 10 times. Copy what you copy, and there would be something different in the way you wrote it. Your L might not be the same, your R might not be exactly the same, right? Robots do it exactly the same way every time, if they're programmed correctly. So we'll look at a video, and that's what the guy says. He says once that sucker has been programmed correctly, it will repeat that program exactly the same way every time. But we can't say exactly this but these guys here have a repeatability. We'll look at some of the big robots, the big Fanics, like 100 nanometers. These little ones around 60, 50 nanometers, where they can actually go back to the same point within something that a size that we just don't understand. High degree of repeatability and with a high degree of precision. So when I first got, when I started driving, you were extremely lucky if you got 100,000 miles out of the car. In fact, once I forgot what it was, you can get an antique license. It was a permanent the license plate, it was a permanent license plate. They did away with that, by the way. Because of now. So now, and if you ever opened up the hood on a car that's got 10 or 15,000 miles on it, it was oil all over the place. You had to clean it up. Even though, because the precision wasn't there, right? You understand that? Now the only reason you open up a hood on a car and the only thing, the motor's dirt, but it's dirt, it's not what? It's not oil. The only way oil gets out of an engine now, of course, if you blow it up or is if you pour it out when you change it. Because everything is made what? Precision. Now they usually don't even use gaskets between the things. They'll put a little lubricant, they'll put a little gel seal thing around there to seal them up. You had gaskets all over the place, and you had to replace gaskets and all kind of stuff in there. So now, if you don't get 100,000 miles out of a car now, getting 100,000 miles out of a car now is nothing. The guy that teaches this over the automotive programs, he says, but it still has a stamina to it. When people go out and look at cars, if it's got over 100,000 miles on it, it still has stamina to it. So when he goes out and buys his cars, his trucks and stuff, he don't buy them unless they got 100,000 miles on them. And because the price does what? Drops down so much on those used cars. So if you don't get 200,000 miles on. So when I was young, cars rolled, the odometer on the cars rolled over at 99,999 miles. I mean, rolled over. It would start back over at 0. And people were really talking about they rolled their odometer over. Now it goes up to what? 900,999. So they added one more digit there. This is the basic makeup of an industrial robot. We have some major components. We got to have a power source, right? For the robot. We got to have the arm. We have the end of arm tooling that we're going to attach. And so the end of arm tooling, most industrial robots, I mean, well over 90%, don't come with a tool. They come with what we call a mounting plate. And that's what makes them multifunctional. So if I was to permanently mount a tool on the end of the robot, then it would do what? That's all it could do. But if I put a mounting plate out on the end of the robot, then we attach the tool that we want the robot to perform. So I can put a welding torch out there. I can put a rivet. Some of them doing riveting. I can put a paint thing out there. I can put an adhesive applicator. These guys are so precise. They are actually used to check. They do quality assurance because they can come up and take these low measurements. We went to a thing in Gadsden where they had a precision measurement, and used to it was a whole machine. Now they just put those things on the end of the robot. The robot just goes up there and just touches and makes sure everything's within calibration. So what happened on that thing? It was a Cartesian thing, so the actual workpiece had to move around while this thing touched. So all it did was come down. These guys can not only come down, they can come down in all different types of angles, right? So it's really ridiculous. We have to have a controller. So the controller is the computer that's running the show. We don't call it a computer, we call it a controller. We have a teaching device. So the art of writing programs for the robot we refer to as teaching. So we don't say we program it, we say we teach it. So teaching the robot is what we do when we're actually doing the program itself. So we have a pendant over there that we use to teach the robot. This is what we actually use to take the robot through its motion. And then plus the teach pendant is your interface with the computer. So not only do we use it to teach the robot, we use it to create programs, delete programs, edit programs. We use it to configure the system too. So we actually use it to set up the actual whole system itself. Then we got some type of data storage device. These are usually external. The computer itself has all types of memory on it. But we need to be able to get these programs off the robot and get programs on it, right? You know what I'm saying? So we have some type of memory interface. It's either going to be compact flash, which is a big card, or a lot of them's going to USB. Most of the newer robots are going to a USB. So that means I can take a little USB thumb drive and put it in there and back up my programs and all that. Or actually get programs. If it's the same robot doing exactly the same thing, we can literally create it on one robot and then do what? Copy it to the others. But they do exactly the same thing, and they're mounted in exactly the same way. Which most of them are. So we'll pause it right now. Let's go over and look at the robots. Okay, any questions on this? Oh, let me unpause the screen. We okay? Any questions? A robot arm, controller, power source, and additional devices. Of course, we have our end of arm tooling, which is what we attach to the end of the arm to do what the robot was purchased to do, right? Teaching device and data storage. A lot of these times these things are called robot arms. Because why? That's what they basically mimic. They mimic the human arm. So if you were laying on your side, then that's basically what we can do. These robots can usually go back, or we can't. We can move them by hydraulics, pneumatics, or electrical actuators. So all the robots that we'll be dealing with are operated by electric. They're electric robots. We saw on the Festo line, we have 2 robots that are pneumatic on there, and on the Amatro line we have 2 pneumatic robots on there too. Now the controller itself is still electric, right? You understand that? We have what we call a jointed spherical robot. Now these guys have, I don't know if it comes in here, but these guys have what we call an envelope or workspace that they operate in. And what they'll do is when we move them around, if we came over here and attached something to it that recorded everything, you know, it's kind of like if you're in photography. If you're in photography, and we call them, what do they call them? When you expose it, you leave your lens open for a long time to capture images. And if you move something around, even though it's moving, it would eventually create sort of like a volume, right? You understand what I'm saying? Time lapse. So if you're a photographer, you set up what we call a time lapse exposure, and that's a lot of way they find meteors and stuff like that on telescopes. Is they'll point it up at the sky and they track it around, and anything that moves within that thing, they understand that it's either an asteroid or a meteor, right? You understand? Just because it's in motion. So if we was to put something on here where it recorded all the position, then it's going to create a volume of space. That volume of space that the robot move in, we call that the envelope. And we have 3 basic envelopes. Anybody that took intro, y'all know what those envelopes are? We have what we call a rectangular envelope. So that means if we filled in all the space around this robot, it'd create a rectangle. We have what we call a cylindrical envelope, and then what we call a spherical envelope. All these robots would fall into the spherical category, but they have a lot more reach and we can do with the old spherical robots. So this is why they picked up the name jointed spherical. We have a 6-axis robot. They're all rotary axis. So all the robots that will be programming what we call 6-axis robots. So axis 1, what are we going to do with axis 1? We'll be able to move the whole robot around. Axis 2, so with axis 1 and 2, we mimic your shoulder. So your shoulder can do what? We can rotate it around, which would be what we're doing with axis 1, and then we can tilt it with axis 2. Well, you do all that with one unit. Now, axis 3, sometimes they call this the elbow. It should be this guy right here. Axis 4 is this guy right here. So what we can do with our elbow, the robot takes 2 axes. It takes axis what? 3 and axis 4. Axis 5 is this. And then axis 6, humans can't do. Humans cannot rotate. We don't rotate at our wrist. We rotate back here, right? So the robot, that 6 axis, allows it to actually rotate the wrist around, which gives it a little more dexterity than what we can do. Of course, the big advantage we have over that robot is this guy right here. The robot don't have this, even though they've been constantly trying to mimic this. It's usually very, very expensive, and so they usually don't mimic this very much. They actually put like a welding torch. So instead of having the robot hold a welding torch, they do what? They mount the welding torch on the robot. So this is our 6-axis robot. Some people refer to this as some people call this the shoulder, even though it takes 2 to get the shoulder. Also, we can refer to this as, we have different names. We can call it an axis. So we call it an axis. We can also call it a joint. And it's also called a degree of freedom. So those three terms are used interchangeably. But a lot of times they'll call this axis right here the shoulder. And they'll call this guy here the elbow. And that's about it. The rest of them are actually used to orient the tool. We'll look at that in a minute. Are we okay? Controller, this is a device which monitors the effects of the operational condition of a given robot. It is a specialized computer, usually. Sometimes we can actually use a PLC, especially on like a pick and place robot, where we don't have to know where it's at all the time. All we need to know is when it's at point A and point B, right? Allows the user to create, edit, copy, and select programs. It holds the current robot code, holds and controls the exact position of all the axes, knows that controls the exact speed of all the axes. This is where we actually can configure the robot system itself, and this contains several input-output ports. Now, of course, the basic makeup of a computer, and this is in that document you're supposed to read, we have to have a way to get information into the computer and out of the computer. And it's just like when I'm sitting here at my keyboard. The keyboard is not actually inside the computer. It's what we call a peripheral, which means it's on the outside edge, right? So what we have to do, but the computer would be useless without the keyboard, or some way to get information into it, and some way to get the information out. And we do this through ports. We're okay? So any computer that we got, it's got some input ports on it, got some output ports, and also got some true I/O ports. The user interface with the computer is the teach pin. So this is what you use to do what we call online programming. Now we got two forms of programming. We have what we call online programming, which means you write your program at the teach pin and at the robot. And then we have what we call offline programming. Offline programming means we would develop the program on a computer, and then we would upload it or download it into the robot. Now, the advantage of offline programming is that the robot is not itself offline while you're writing programs. But offline programming is applications are not cheap. So that's why we only have one. So if you're in the manufacturing and computer simulation, you'll do offline programming, which is pretty neat. Everybody okay so far? What is that? That's an alarm for something. That's not. Oh, okay. That's all we're gonna do today, guys. I got to do the help desk.
Glad to remind you.
Huh?
You'll be glad to remind you.
Yeah, that's why I put it on my